Hello friends, in this lecture we are going to understand the analysis of merge sort. So let's get started. In the first part of this video, we'll be covering the merge sort analysis, okay, and we are only going to calculate the space complexity of it. So let's get started. Now, you see, this is the merge function of the merge sort. In this merge function, what happens? In this merge function, we take two array, okay, we divide it into two parts. After dividing it into two parts, we again merge it. When we merge it, we see to it that it's a sorted array. So for doing this, there is a particular operation that takes place. So let's understand what happens in that. So now in this particular thing, you can see that I have an array A, okay, and suppose this array A is passed to the merge function. So what happens? So we have this Q, which is also passed. So you can see we have A, we have P, we have Q, and we have R. So A is the array, the P is the starting index of that array, Q is the ending index of that array, and sorry, R is the ending index, and Q is the midpoint of that array. So now, in this you can see P is the starting index, R is the ending index, and Q is the kind of midpoint, right? Now, so to go get started, okay, understand how Q is calculated. Okay, so Q is calculated by it is P plus R, okay, divided by 2. And then we take the lower bound of it. So it is 1 plus 8, which is 9, divided by 2, which is 4.5, and the lower bound is of 4.5 is 4. So that's why Q is pointing to 4. So that's how we get the value of Q. Now, this entire thing is passed to the merge function. So how does the merge function work? It makes two other arrays, L1 and L2. So L1 and L2, you can clearly see, okay, that it is the first part of the array. So we copy the first part of array A from P till Q and bring it into L1. What happens in L2? L2, it takes the second part of the array A. So we take it from 5 to 8 and we copy it over. Okay, so these are the two extra arrays which are created. Now, what would be the size of it? Obviously, if we add up the size of L1 and L2, that is equivalent to A. Okay, so it is suppose this is n elements 1 to 8, so n is equal to 8. So even here you can see that we have 4 elements here and 4 elements here. You can still see an extra infinity, but that is a constant space. Okay, so this is a kind of we'll say that 4 and this 4 is again 8, which is n, and we will say that these two extra spaces are occupied, so it is n plus 2. So finally, the space complexity of merge function in merge sort is n plus 2. So we can denote it by big O of n. So that is why we have the space complexity as big O of n. Now, to understand the working, we just need to understand that we have two arrays and we have to merge these two arrays again back into array A. So for merging these two arrays, we need to understand that we'll be comparing the elements of these two arrays. So you can see that I compare the first element of L1 with first element of L2. Now, as I compare that, I see that L2 is smaller, so I bring L2 into array. And then I increment the pointer of L2. So now the pointer of L2 is pointing to 4. Now, again, we check that the pointer of L1, which is pointing to 3, and pointer of L2, which is pointing to 4. Which one is lesser? So 3 is lesser. So again, we bring 3 to array A, and then we increment the pointer of L1. Now the pointer of L1 is pointing to 5, and pointer of L2 is pointing to 4. So we compare 4 and 5. 4 is lesser, so 4 comes down. Now we increment the pointer of L2. It comes to 8. Now we compare the pointer of L1, which is 5, and pointer of L2, which is pointing to 8. So 5 and 8, so 5 is lesser, so we see that the 5 comes down into the array A. Now we increment the pointer of L1. Now L1 is pointing to 7. So 7 is compared with 8, and we see that 7 is lesser, so we bring 7 down to the array. And we increment the pointer of L1 to 10. Okay, now 10 and 8 is compared. 8 is lesser, so 8 comes down. The pointer of L2 is incremented to 9. So 9 is still lesser than 10, so you see that 9 comes down to the array A. And now the pointer is of L2 is pointing to infinity. So into infinity or some higher number. So now obviously why do we have infinity? You'll understand now. Because now that this the 10th element which is left in L2, L1, the 10th element which is left in L1 has still to be brought into the array A, but it has to get compared to something which is much higher than 10. Otherwise, this operation of bringing 10 into array is not possible. So that's the reason why we are now pointing to infinity in L2. So when I compare 10 to this infinity, okay, I bring the 10th element into the array A. Okay, so this is the operation. Okay, this is the merge operation that is going on. Okay, and this is the complexity of the merge function. Now let's understand the complexity of merge function. So what complexity are we talking about? We are talking about space complexity, and the space complexity is big O of n. Are you getting it? Okay. Now, you need to understand that when we are talking about space complexity, we are talking about the space the array occupies. So this is the extra space. So we in space complexity, we only talk about the extra space occupied. Okay, and we don't talk about the space occupied by the original array. So this is the input. So we don't consider the space of the input. We only consider the extra space needed for running out that particular algorithm or that function. Now, let's talk about time complexity only of the merge function. Now, when we talk about time complexity of merge function, so we need to understand that how much time would be required to merge these two particular arrays. So finally, you need to understand that in the time complexity as well, we are working on n elements. Now, n elements, okay, which are broken into two parts, L1 and L2, okay, and then finally they are merged together. So it's just still the same n elements that we are working on, right? So it's not like we are working extra or something, okay? So let's come back to the entire algorithm. So you can see first we get N1 and N2. So what is N1 and N2? N1 is this particular thing. That is from 3 to 10. This is this four elements. What is N2? From 5 to 8. Again, it is the size of four elements. Using N1 and N2, we bring the first four elements into L1. And using N2, we bring the first four elements into L2. So you can see this is happening. We get N1 and N2. Then using N1 and N2, we make the L array, we make the R array. Then we initialize infinity to the end of those L and R array, and then we start with the comparison for loop. Using the for loop, we do the comparison, and we make the array again, which is a sorted array, right? Now, what would be the complexity of this for loop, right? The complexity of it will be n by 2, right? Then the complexity of this would be again the other for loop will be n by 2. So it will be n by 2 plus n by 2. But finally, in here we are going from P to R entirely. That is this is the entire length of that particular array from P to R. So that means here we are having a complexity of n because this loop is going to run for n times. So it is n by 2 plus n by 2 plus n. So whenever we have like a complexity of n by 2 plus n by 2 plus n, we take the most significant part of it. So n is having the highest degree over here, understanding? And so we can ignore n by 2, n by 2. And so the time complexity of this particular function is also big O of n. Okay, so I hope you have understood the merge function. Okay, let's understand it with the help of a example also. So you can see over here that we have this elements. Okay, single elements. Okay, now so let's consider that every single element. Okay, over here. Okay, when we go bring it into the merge function. So this 12 works as L and this 8 works as R, the L array and the R array. So you can see now when they are merged together. Okay, it makes it 8 comma 12, right? Then again, when I'm going for merging of 8, comma 12 and 6, let's consider that this is the L array and this is the R array. So when I again go over, obviously 6 will be compared with 8 and 6 will be brought in first. Now, after 6 is compared to 8, the pointer of this particular array will point to infinity in the same array itself, right? And 8 will compare to that infinity and brought into this array. 12 will be compared to that infinity and brought into this array. This is how it. Now again, you'll see that here 1 comma 10. Okay, so this is L array, this is R array. Okay, 1 is less than 10, so 1 comes first and then comes 10. Right? Then we compare 1 comma 10 and 2. So we can see 1 and 2 is compared, word comes first. Okay, then 10 and 2 is compared, 2 comes first, and then finally 10 comes in. Then finally these two areas merge. So this is again an L array, this is again an R array. So you can see that 6 and 1 is compared, 1 comes in. 6 and 2 is compared, 2 comes in. Right? Then 6 and 10 is compared. So 6 comes in next. Then after 6 goes 8 and 10 is compared. So 8 goes in. Right? Then 12 and 10 is compared. So 10 goes in. And finally 12 goes in. Okay. So this is how the merge function works. I hope you have understood the topic. In the next video lecture, we'll understand the merge sort function and we'll understand the time complexity and the space complexity of merge sort function. Thank you. I hope you have enjoyed the video. If you have understood it, kindly like, share, and subscribe. Happy learning. Enjoy algorithms. Thank you.